Eureka! The story so far. Stationary things don't want to move. It takes a force to move them. Force equals mass times acceleration and is measured in newtons. When a force moves something through a distance, work is done. Work is measured in joules. 1 joule is the amount of work done when 1 newton of force is applied through a distance of 1 meter. And now, kinetic energy. Because of inertia or laziness, this billiard ball doesn't want to move. In fact, it would sit there all day minding its own business if another ball were not to come along and knock it into the pocket. Because the second ball forces the first one to move. Whenever you have a force acting through a distance, you know that some work has been done. Fine. But where did this work come from? The second billiard ball, naturally. But what's so special about this ball that enables it to push the other one around? They both have the same mass, don't they? And they're both being pulled down to Earth by exactly the same force of gravity. So what did the second ball have that the first ball didn't? Movement. It was moving and the other one wasn't. And when you have both mass and speed, you have the ability to do work. You can use your movement to get other things to move. In a sense, you have work in you. Physicists, keen as ever on borrowing words from other languages, went this time to Greek and found that the Greek word for in is en, and that the word for work is ergon. When you put en and ergon together, you get energon, which comes out as the English word energy. And the physicists agreed to use this word to mean the ability to do work. So the moving billiard ball had energy. The origin of this energy was, of course, the billiard player, whose arm had work in it, or energy, because of its movement. This energy was transferred to the cue when the arm made the cue move, which in turn transferred the energy to the billiard ball by making it move, and hit the other ball, forcing it to move into the billiard table pocket. In each case, a number of joules of work were done. Arm moving cue, cue moving ball, ball moving ball. But since work is merely energy in action, and there's no work possible without energy, we might as well say that a number of joules of energy were expended each time. And that's exactly what we do say. Both work and energy are measured in joules. Think of joules being transferred from an energy box to a work box, and then to a force times distance box. Joules of energy are spent not only by billiard players, but by hockey players and soccer players, carpenters and ditch diggers. And all the energy to do all this work is only made possible by movement. So that they wouldn't forget this, the physicists went once again to their Greek dictionaries and found that the Greek for movement is kinema, a word that film producers have also borrowed to mean moving pictures or cinema. But the physicists decided to keep the K and to call the energy of movement kinetic energy.